Okay, here are the notes for N8-5. So all types of motion problems. So you will have one similar to this on the quiz. So make sure you practice these problems and check your answers. Remember, I emailed you the answer keys, so just go through and check your answers as you go through these problems. Okay, so it says it's the bottom of the ninth inning with 2 outs and the Tigers are behind 6-3. However, the bases are loaded and Nick is at the plate. He swings. It looks like a hit. Is it a home run? Well, we don't know. But here's the information so we can figure it out. It says he makes contact with the ball 3 feet above the ground at an angle of 20 degrees. Notice it's degrees, so you're going to have to change your calculator back to degree mode. So at an angle 20 degrees and a velocity of 150 feet per second. He hits straight toward center field. At the moment the ball is hit, there's a 5 mile per hour or 8.8 feet per second wind blowing straight in from center field. So draw a sketch of the situation where here's your guy, he's got his bat in his hand. When he makes contact, the ball takes off at a 20-degree angle. So that's what this says right here. So you have your horizontal placement, you have your vertical, you make a right triangle, this is 20 degrees right here. And then of course it's taking off at a velocity of 150 feet per second. So after 1 second, it's 150 times t, because after 1 second it's 150 feet, 2 seconds, 300 feet, etc. But it's also 3 feet above the ground. Remember, there's there's wind coming in toward him, so it's going against the ball, and that was 8.8 feet per second. So it says write parametric equations to represent the situation. Well, you have your horizontal equation, which is your x right here. So you're going to use SOHCAHTOA in order to solve for x. So this is the adjacent side. We know the hypotenuse is 150t. So cosine of 20 degrees equals adjacent over hypotenuse. Isolate the x. So x equals 150t times cosine of 20 degrees. But don't forget we had the wind, which was working against the ball. So this is the horizontal displacement. So we have to work the wind against it. So in order to go against it, it's going to be 150t cosine 20 degrees, your initial velocity for your horizontal, minus the wind working horizontally against it at 8.8t. Excuse me. So then we have our vertical. Well, that's just our y value. So you set up your sine of 20 degrees equals opposite over hypotenuse, or y over 150t. Isolate our y, so we get 150t sine 20 degrees. But your vertical is the formula we just learned in the last lesson, which is negative 16t squared plus the initial velocity times t plus the initial height. So we have negative 16t squared. Well, our initial velocity is now the y value, which is 150t sine of 20 degrees. And then we have our initial height, which was 3 feet above ground, according to this. So have a moment, look through that formula, pause, reread it, see if you understand where all those things go, and then continue on. We're not going to worry about your window. You won't have to put any of that information down, but we will ask you questions related to that scenario. So it says calculate when and where the ball hits the ground. So that's what we want to do now. So grab your calculator and you're going to go to your menu and go to parametric equations, which is number 3, and you're going to type those 2 parametric equations into your calculator. So if you need to pause and do that, go ahead and do that now. When you go to graph it, your window probably doesn't make any sense. So you want to think about what would make sense. You know, how many seconds do you think it's going to take the ball to fly through the air before it hits the ground? Maybe you're going to guess 10 seconds initially or 5 seconds. That's okay. How high do you think that ball is going to go? So you need to create your window based on what you think makes sense, right? Or you can do zoom fit, I suppose. When you do zoom fit, it doesn't quite look like this. You can adjust your window though as you go. So really the only way to answer these 2 questions is to do the trace. You need to do the graph trace in order to answer these questions. So you go to your menu, you go to Analyze Graph, or sorry, not Analyze Graph, you go to Trace, and you go to Graph Trace. And it should bring up this menu down here where it has X sub 1, Y sub 1. So it's telling you your horizontal component and your vertical component for each time that has passed. So I changed my trace setting to be 0.1 so I could see better what was happening, right? Or how often. So you can change your trace setup. Here, your trace step to be 0.1, right? And that will help. So then you'll get your values as 0.1. And then we can see over here it's changing to be 0.1. So after 0.2 seconds, that's where it is. After 0.3 seconds. So calculate when and where the ball will hit the ground. So I go all the way over here until I get to where the ball is going to hit the ground. And that means where it's going to become 0 height. So we're at 410 feet. This is your horizontal component. So it's 410 feet away from home plate, and it's still 8.28 feet above ground at 3.1 seconds. So then I push my right arrow key, and now I'm 423 feet away from home plate. I'm 3.33 feet above ground at 3.2 seconds. Well, what happens when I click it one more time? Well, my height went to negative. So you now know that somewhere between 3.2 seconds and 3.3 seconds, the ball hit the ground because it went from a positive height to a negative height. So that's why this answer is between, so you're going to have a 3.2 to 3.3. You're not going to have an exact answer because you can't find the 0 or the maximum using this information. We can only use this right here. So we can find the maximum height that it traveled, and then we're getting an approximate distance that it traveled. So notice my distance away from home plate, it was 423 feet, so it depends on your settings, I suppose, to about 436 feet from home plate. So that's where the ball finally hit the ground. So suppose that he hits the ball toward a 20-foot high fence, which is 400 feet from the home plate. So 400 feet from home plate, well, let's backtrack here. 400 feet is in between 3.3 seconds and 3.1 seconds. And at 396 feet from home plate, the ball is at 12.9 feet height above the ground. So is that ball going to go over a 20-foot high fence? And the answer to that hopefully is obvious because of the height here, and that answer is no. So no, that's not going to happen because it's not higher than 20 feet at 400 feet away from home plate. So I would again just use the trace button. I wouldn't worry about this right here. And we can see that it's not going to happen. So go ahead and try the worksheet on your own, see how you do, and check your answers. And I'll see you. Just good luck on the quiz Monday. Do your best, and if there are questions, we can review them on Wednesday's class for the review day, and then hopefully you'll be ready for your test after the Chinese New Year break. Bye.